Okay, everybody, let's go and try another example right here of graphing, sketching a graph of a rational function. This time, a little bit of a slight change from what we saw the last case. This time, we go through all the same steps. We start by determining the domain. In this case, there are no common factors in the numerator and denominator that we can note, but we will know that the domain is defined as the set of all real values where x is not equal to 2. So we write that in the set builder notation as is appropriate. Any notation actually will work that is appropriate, but x such that x is not equal to 2 in the set builder notation seems to be the most agreeable. Let's try a vertical asymptote. Where do we find the vertical asymptote? Remember that we reduce the expression completely if there are any common factors. Since there are no common factors, it happens to be that our vertical asymptote coincides with the value from our domain, so we will express the vertical asymptote as the line x equals 2, and we'll sketch that in here on the axis with a dashed line like this. Doing my best to kind of keep it on that same line. Piece of graph paper is always really handy for these kinds of graphs. And I label it vertical asymptote at x equals 2. Now let's take a look at our horizontal asymptote. Horizontal asymptote this time will be a little bit different because we look at the degree of the numerator and compare it to the degree of the denominator. In this case, the degree of the numerator it's a first degree polynomial, x to the first. And the denominator is also a first degree polynomial, and since the degree of the numerator equals the degree of the denominator, we set our horizontal asymptote at the y value of the leading coefficient of the leading coefficient. Remember, the leading coefficient is not the first number in the expression, but the coefficient attached to the highest degree term. Another way of writing our function f of x would be the function y equals x divided by negative x plus 2, which means that our horizontal asymptote will be the line y equals negative 1 this time. So we'll sketch a horizontal line to represent our horizontal asymptote at y equals negative 1. Next, we need to find any x and y-intercepts. Remember that x and y-intercepts occur at zeros of respective variables. So the y-intercept is going to occur at the point where x is equal to 0. And in this case, that happens to be the coordinate point 0, 0. By the way, all y-intercepts occurring at 0, 0 are also x-intercepts. Why is that? Well, in this case, remember that all x-intercepts here, 0, 0, that's also a place where it crosses the x-axis. The x-axis and the y-axis happen to meet. So our x-intercept and our y-intercept happen to occur. So 0, 0, that seems to be the only point we're getting out of our intercepts this time. Should label it here. So the next thing would be to check our symmetry. But in this case, f of x is neither even nor odd again, so we can't really use that fact to help us graphing. We'll come to a graph eventually where it does. Right? But let's check the behavior near the asymptote. So what we need to do now is we need to find x values and some corresponding y values to plot on this graph. And the best place to go is near these asymptotes. So let's start with 0, 0. We know what's happening right there. Passes through the x and y axis right there, the origin. What happens at x equals 1? Well, at x equals 1, y would equal 1 over 2 minus 1. Well, that's really easy. It must go through the point 1, 1. Let's try 2. Well, we know what happens at 2. That's our vertical asymptote, so that's no good, right? That's our vertical asymptote. But let's go to the right of that to 3. Well, in this case, y will equal 3 over 2 minus 3. So y would equal negative 3. So we know we're going through 3, negative 3. Interesting, okay. And what happens at 4? Well, y would equal 4 divided by 2 minus 4, which is to say 4 divided by negative 2. So we're going to get 4, negative 2. All right, I kind of get an idea what's happening right here. Now you can keep going right here. For example, you might find that if you were to try at negative 1, you're going to get negative 1/3. Or other points, but look at what's happening. This graph is coming along this horizontal asymptote, and as we come from the left, the graph tends towards positive infinity. If you just follow the bouncing balls as they go from left to right, that's what happens. And as we go from a vertical asymptote at x equals 2, the graph seems to be coming up along that vertical asymptote and increasing until it approaches that horizontal asymptote at y equals negative 1. So this is the graph of our function f of x equals x over 2 minus x.